Cool. Nice. People in Florida? Jealous of the weather. That's true. We've got a friend I like to visit down there, roughly the February time frame. Middle of the summer gets a little dicey, yeah, when it's still cold here. Yeah, I'll go down and see her when it's like ski season here, and then go down there if I've got like some East Coast work, visit Florida on the way. If it gets to the middle of the summer, it's almost unbearable.
It's just
Yeah.
if you're not used to it. See, I grew up on the East Coast, so I kind of got used to it.
Oh, what part?
North Carolina.
Okay, I grew up in Tennessee, Johnson City.
Oh,
Yeah, about 3.5 from Charlotte,
yeah.
just right outside of Knoxville.
I'm actually I grew up in a small town west of Charlotte. But
Okay.
It is that direction. Yeah.
That's cool. Small world.
It is. I'm learning that every day.
Yeah, it's amazing.
Kind of the same experience wherever I've traveled, like internationally. I run into people that, you're from where? You know, like somewhere either Virginia or South Carolina or Tennessee or
Yeah.
wherever, you know.
It's amazing. I feel like it's kind of like maybe underrated the amount of like, I don't know, like really like good and smart people from that part of the country. Because a lot of people will just kind of grow up there and stay there and stuff like that.
There is that.
And you have a lot of really good schools, like in between, like Charlotte, and then like kind of getting up towards Virginia, and then over to Knoxville. Like you've got the University of Tennessee, you've got Virginia Tech, you got Radford, you got all those colleges in Charlotte. Like there's a lot of education in that area that people just don't even think about.
You know, in North Carolina, you have Duke,
Oh, in the Triangle.
NC State,
I mean,
Chapel Hill,
yeah,
and then I guess Charlotte or UNC Charlotte.
yeah,
Come onto the scene more.
yeah. Go 49ers,
School,
right?
It wasn't
Yeah.
that big when I went.
Yeah.
But it has exploded.
Cool. It's pretty interesting to see that area grow, especially like around Charlotte. They got a bunch of people that have come down from New York, from what I understand, like from finance. Yeah, so like there's a big influx of money.
Yeah, so like just north of Charlotte, Mooresville, and Davidson, Lake Norman area.
Yeah.
Just crazy.
What is that one like that Duke Energy dumps a bunch of hot water in? Lake Wiley? Feels like a hot tub. This is right outside of Charlotte.
Lake Wiley. Yeah. Yeah. That's the one on the South Carolina side.
Oh, okay.
Lake Norman's the one that they have several. They have a nuclear plant.
Oh, maybe that's what I'm thinking about.
They have
NASCAR drivers have fancy houses out there. You want a drink? You good?
So you need software too? Yeah. How you gonna adjust that?
Everyone's got some pizza and some LaCroix and waters, etc. So first of all, thanks for coming out. AWS Denver. We are also rebranding as the AWS Meetup Group, and we'll be taking our show on the road. I think next month, or later this month, we have an event in San Francisco. Next month, we have an event in San Antonio. No, Austin, is that correct? Yeah. And Orlando. So we are changing our branding. So this slide might be a touch out of date. Apologies for that. So today I'm going to do a dive into Terraform and Pulumi, the second part of our infrastructure as code series focused around AWS. The first one was focused solely around cloud formation. So again, thank you for coming out. A little bit about me. My name is Kevin Tin. I'm a cloud application architect at Worldwide Technology. Serve as practice lead over there. Been in the industry for about a decade. Background in software development. Started in the .NET world, C#, VB.NET. Try not to do much of the VB.NET stuff anymore. Got into some JVM development, namely in Scala. Done throughout the portion of my career some work in JavaScript as well, both on the front end and the back end. You all are interested in. Then also application architecture most recently, so focused mainly on AWS, Azure. quick intro, overview of infrastructure as code. We'll take a quick look at what we did last time in part 1 of this series. Then we'll dive into kind of a hello world of Terraform, setting up Terraform CLI, etc., command line interface, that is. Then I've also prepared Terraform for a IaaS hosting stack, so that includes an ECS instance and a public subnet, RDS instance that's multi-zone availability across 2 private subnets, so we'll get into deploying that as well. Then we'll jump into a product called Pulumi, which allows you to write coded infrastructure in probably the same language that you are writing your actual software in. It's a product that we're really pretty excited about at Worldwide Technology. And then we'll get into actually deploying some code or some resources via Pulumi. And then look at, say you want to convert from Terraform to Pulumi, there's a tool to do that. Some caveats, including you have to be on 0.11 of Terraform. We'll jump into that as time allows, and then finally just go through some Q&A. So just a quick mention here. A lot of the stuff we are working from is in a GitHub repo. In the comments for today's meetup, there is a link to that repo. Also, kevasync/aws-meetup-group-terraform will get you to that repo on github.com. So to get into coded infrastructure, just at a very high level, so what you are creating is a declarative representation of a known good state of resources. And so this results in a repeatable process that allows for high fidelity duplication of environments. For example, if you want to create your development environment, and then you want to ensure that you are going to have the same environment in staging or test, and then the same environment in production, coded infrastructure gives you the ability to fully replicate with high fidelity the environment. So that can work both directions, right? So you want to have, you coded out your production environment and you want to develop or test against the same resources. Going backwards in that process, it allows you to produce to lower environments the same environment that you're going to be seeing in production. So taking some of the guesswork out of your deployments to production is certainly a good thing. I think we all have better uses of our time. And so also another usage of the coded infrastructure, known good state here, is really to, in the event of some sort of error within your application where your server seems to just be borked, you can go and recreate it and get your application back up off its, back on its legs, back rolling. And then you should probably go ahead and dive into what caused the problem, but get your product back on its feet before you start to really dive into that, if at all possible. Additionally, it allows for source control and integration into CI/CD pipelines. And so with this being the case, you can code your infrastructure and go back to the last version of it if you need to go and say, well, what's changed? Well, it turns out we're in a different subnet at this point. We need to create new security groups, etc. So it does give you that version control, as well as the ability to incorporate it in your CI/CD pipeline. So we use the Terraform plan and deploy step in a product I'm working on. And so this allows us to update the iterative nature, the actual infrastructure that the product is running on. And so previously, we did basically the same class with CloudFormation using the tooling that's native to AWS. And so during that, just a brief overview, I think almost the same overview of coded infrastructure, and then actually CloudFormation templates to create EC2 instance, VPC, RDS instance, etc. So, and I will post this slide deck somewhere convenient and put a link on the meetup so that you guys can get into these links. So firstly, let's take a look at what is Terraform. And so it is an open source infrastructure as code software tool created by a company called HashiCorp. They are on GitHub. You can go out and perform pull requests and try to get them to update the platform as you need or fix bugs, etc. So it's just HashiCorp/Terraform in GitHub. First released in 2014, and firsthand I can say that we've seen very wide adoption of Terraform. It would be something that if you're not already into from a career standpoint would certainly be very good for your career. And so it enables the definition and provisioning of data center and cloud infrastructure using a config language called the HashiCorp Configuration Language, HCL for short, or JSON. And so the goal, as stated by HashiCorp themselves, is to enable building, changing, and versioning infrastructure safely. So that plays into the CI/CD and version control aspects of what I mentioned quite nicely. And it should be noted that you can provision on many different platforms, from IaaS deployments, in your own data center to into cloud platforms. They support Alibaba Cloud. They're pretty far ahead, in my opinion, in terms of providers. Into PaaS offerings and software as a service offerings. So you can actually go out and provision GitHub repos using Terraform, for example. So with all that being said, two flavors of Terraform exist. Terraform Cloud, which is software as a service offering, and then also Terraform Enterprise. And so Terraform Cloud is pretty much exactly what it sounds like. You go to a website, you sign up for an account, you tie into that account in your CI/CD pipeline. It keeps track of your state within the Terraform Cloud platform itself, and that's free. So it's a really nice free product. If you find the need to host on-prem, for example, for firewall reasons, you can't allow Terraform Cloud to look into your data center to see what's been provisioned, for example. There's another offering called Terraform Enterprise, which is basically a private instance of the Terraform Cloud. It doesn't have limitations around resources, so you might use Terraform Enterprise with a cloud provider such as AWS if you're going to go past the throttling on the number of limits. It allows you to get into some things such as auditing, some single sign-on capabilities, etc. So it's certainly, once you go into a larger enterprise, or you have a customer that is a larger enterprise organization and they need the accountability and auditing, then that would be something that you may look at. With all that being said, for this lab, we're just going to do some introduction to Terraform exercises. So we are not going to use any kind of persistent state management. We're just going to do it through the Terraform command line interface, which stores your state locally. So that's the tidbit about Terraform Cloud and Terraform Enterprise. Is keep in mind, for a production environment, you'd want to use one of those two. But for us just doing kind of developer level tasks at this point, using the command line and local state storage is sufficient for what we're doing tonight. And so to get into some kind of basics of Terraform, in my opinion, probably the core concept is the provider. And the provider is responsible for interacting with the APIs of the system to which you want to provision to. So there's a provider for AWS, there's a provider for VMware, Azure, GCP, Alibaba. If you want to get into more PaaS type offerings, Roku or GitHub, or you can even provision things with Terraform on Terraform Cloud, or if you get into analytics and app telemetry, stuff like Datadog. So I think the takeaway there is you really have a wide range of targets to deploy resources to, given the amount of providers that Terraform provides. So as I mentioned, this can include GitHub repos. You can provision CI/CD pipelines. You can provision your entire data center. You can provision your cloud footprint in any of the major cloud providers. You can get into serverless cloud components, etc. It's really a pretty extensive list. I am going to get out the slideshow real quick. Let's go take a look at the just the list of providers, because honestly, it's really, really impressive. So within here, you'll see kind of big hitters such as Google Cloud Platform or GitHub and GitLab. You can get into Helm charts for Roku, Azure Active Directory, pretty interesting there. Do things in the Chef platform, MongoDB Atlas. If you want to go onto Mongo's cloud PaaS offering, you can provision things there. And then also a bunch of things, honestly, I've not heard of. I'm not sure what Null is, to be quite honest. But
So you can put in your own scripts into one resource provider.
oh, is it? Nice. That's cool.
You do mobile with it?
Say what?
You do mobile with it?
Oh, yeah, for sure.
But sometimes you need to force something out.
Oh, nice. Do you by chance know what Dome 9 is?
Sorry?
Do you by chance know what Dome 9 is?
No idea. Sounds like some startup.
Yeah, I agree. I agree. Interesting. I'm about to look into the null provider. Thank you.
Yeah, it's only time I've ever used it is to like, if there's a specific like Python script that needs to reach out to something that doesn't have RESTful dependency.
Oh, okay.
You can just force it to run Python scripts during your provisioning and then just manually inject it into your dependency graph.
Oh, that's cool. So basically, whatever you have network access to, and you have like a custom library to automate, you can use the null provider
I'm
to.
not saying you should. I'm just saying it can happen.
Sure. Yeah.
It's an anti-pattern and should be avoided if at all possible. But sometimes you have to work with legacy stuff.
Yeah. Absolutely. Yeah. That's cool. Awesome. Thanks for sharing.
Yep.
All right. And back into it. So now that we've taken a look at the list of providers, it should be noted, I think one of the, things that is maybe like a falsehood around Terraform is like, hey, let's use Terraform and allow us to provision into multiple cloud environments, for example. The different providers have different syntaxes, different resource identifiers, so it's not just like I'm going to write Terraform to provision a bunch of stuff in AWS and then we get a new CTO, we're going to Azure. It's as simple as changing the provider. The syntax and the properties, they do change, and so be aware of that. You can get some vendor lock-in based on the providers. So Terraform has a three-phase approach around write, plan, and apply. And so based on those three phases, there are some concepts within Terraform I wanted to cover. And so firstly are the configuration files, very much in the write phase of the approach. And so within that, you actually declare the resources that you want to provision. And secondly, we have the execution plans falling within the plan phase. And so this is the planning step. Terraform creates an execution plan. On your first run, this turns into I'm going to create all the things. On your second run, it may look like I'm going to modify some properties. If you want to change the security group that EC2 Instance is in, for example, it may go ahead and reprovision the EC2 instance completely. And so with that being the case, Terraform will try to not recreate the world if at all possible, but sometimes if you make big enough changes, you will have resources that are destroyed and then recreated. And so the resource graph that Terraform uses is a way to map dependencies. And so non-dependent resources are instantiated firstly, and then resources that have dependency wait until the dependent resources, if you will, are instantiated, and then they are created. And so in that way, you get a certain level of parallelism, but you also get the ability to hold off on creating something. For example, if you need a subnet to put your EC2 instance in, the subnet will be created first. And then change automation is another concept within Terraform, part of the apply step or the actual creation of the resources or the modification of the resources. Change sets are created and applied to the environment based on the execution. And so at this point, we're going to get into some hands-on labs. So Terraform plays pretty nicely with both Windows and Mac. I am a Mac user, so a lot of the instructions are kind of Mac first, if you will. If you're using Brew on Homebrew on Mac, it's Brew install Terraform. If you're using Chocolatey on Windows, it's just Choco install Terraform. There is also an option to manually download the Terraform client and install it. If you do that, you'll need to put the binary location inside of your path so that you can access it from anywhere in the command line, or you'll need to keep it local to the directory that you are working in. And so to take a quick foray into the command line, let's go ahead and go through the steps to install Terraform. So at this point, I'm using Brew. Go ahead and install. Actually, since I've already got it, I will do an update to Terraform. So, yep. So needy. So go ahead and get Terraform installed. And we'll take a couple minutes here just if anyone's installing it, we'll give everyone adequate time. Cool. So I've got some things going on with the product called TFM that supersedes Terraform. We can get into that later. So as we're installing the Terraform command line, just kind of to get a feel for the room, how many people have worked with Terraform before? Cool. Nice. So we got a good mix of experienced and newbies. Very cool. So I'm going to go ahead and bounce on to the next step. So at this point, in order to run Terraform locally and interact with AWS, you need to configure some AWS credentials. And so let's go ahead and jump into the AWS portal. So your portal may not look exactly like mine. I have a account through my company that I'm using, our sandbox. So if any issues pop up, let me know and we'll try to work through them. But at its core, it's all pretty much the same thing. Into the IAM service, At that point, get into users. And to create a command line programmatic user, if you will, click the Add User button. Based on the defaults and some of the parameters in the Terraform scripts, you'll want to go with AWS Meetup Group key, if you will. And so let me actually... I'll go ahead and open up the repo. And so when I say the defaults, I'll show you what I mean. And we'll get into what this means a whole lot more later. But the EC2 key name that is the default within the variables file is AWS Meetup Group key, separated by dashes. So you'll certainly want to go with that. I've already created one, so I'm going to create a key 2. And then you'll want to select programmatic access. And so once you select that, get into the permissions. So within our AWS account, we have a group called admins. And so you can also copy from existing users, or you can attach into policies. And so, for example, you could assign this user the policy administrator access. So if you do not have an admins group, go with administrator access from the policies. So for me, I'm going to go with the group since I have that handy. It'll give you the review screen and then finally create user. And so it'll give you an access key ID and it'll also give you an access key. So you'll want to record that access key and keep it somewhere handy. We're going to use it pretty soon when we configure the AWS command line. I'm not going to show you mine for security reasons. And do it. Living on the edge, man. So give everyone a couple minutes to create the command line account. feel free to shoot questions my way if you have any issues. All right, I'm going to go ahead and jump along. So at this point, the next step is to install the AWS CLI. Again, if you're on Mac, brew install AWS CLI works quite well. There's also a bundled installer, which I would just use brew personally, or homebrew personally. On a Windows machine, there's an MSI installer that you can use. I'm not sure if there's a chocolatey package. Surprised me if there wasn't. So let's also take a pause here to let people install the AWS command line. Did you all get pizza? Everyone get some food and bev? Nice. Okay, so it seems like for the most part we are in a pretty good spot to get going based on the room. So at this point you will want to, if you have not already, configure the AWS credentials. And so what this looks like from a terminal is just AWS configure. And it will bring up a prompt for, your access key ID, which was here. It'll ask for the secret access key itself, which is what's obscured. It'll also ask for a default region and output. I tend to go with US East 1 for these exercises and JSON, because why would you want XML? And so if anyone's working through that, let me know if you have any issues. Okay, so at this point, let's go ahead and kind of do a hello world with Terraform. And so to do such, I'm going to go ahead and nuke this, clear this out. I'm just going to go ahead and make a directory and switch into it. For example, I'm going to call it test, nothing in it. Within the instructions here, I said create a directory called tf-hello world. The name of the directory is not super important, to be honest, at this point. So create a directory, and within it, a file called stack.tf. So I'm going to create stack.tf. And it is an empty file. So at this point, we need to create a Terraform configuration. I've got it on the slides, as well as if you go to the repo itself, it is in the README file. And so at this point, it has a provider to use AWS, specifies a region, and we are going to create a VPC and a subnet. So let's go ahead and throw that into the file. Cool. So just a quick overview of what we're creating. We are creating a VPC and a subnet. We're going to give the CIDR block to the VPC to be 192.168.225-0 with a -24 subnet mask. So that's going to give us 255 addresses available within our VPC. Then we're going to create a subnet. We're going to associate it with the VPC created above. This is probably a good point to talk about that resource map again, where this subnet is dependent upon this VPC. The VPC will be created first. And then we are going to give this subnet, the CIDR block, 92.68.225-25. So we are going to give it half of the addresses available And then from there, we're going to place it within availability zone US East 1A. And on both of these, we are going to assign it a tag cost center equal tf-hello world. Cool. So just a quick sanity check. This is what is in the stack.tf file. And so at this point, we are ready to deploy our first Terraform resources. Pretty cool. Cool. So the first thing that needs to be done is to initialize the Terraform stack. So within the folder that you created your stack.tf file, just a quick Terraform init. So that's going to go and download the provider plugin, AWS in this case. And this does take a couple minutes. Cool. So we have initialized the Terraform project. And so at this point, we have a .terraform entry in our directory. So at this point, if we want to look at what Terraform would do in the event of being applied, we can do a Terraform, Terraform plan, which creates that execution plan. So this is actually going to go out to AWS, see what has been instantiated, and see what needs to change, what needs to be deleted, and what needs to be added. And so in this case, we have our main subnet, as well as our main VPC. And so it's going to go ahead and, if we were to apply this, it's going to add 2 resources to our AWS account. 0 will change, and 0 will be destroyed. And so with all that being said, let's go ahead and do just that. So at this point, Terraform apply. And this is going to create resources in Terraform. There's a switch to not ask it to prompt you for confirmation. But I'm just going to go ahead and go through the confirmation. So on the command line at this point, it's going to go ahead and show you what it's creating. So firstly, since the subnet's dependent upon the VPC gets created first. And then secondly, the subnet is created. And so you can actually get out and start seeing some pretty decent information here. For example, the ID of the VPC that your subnet was attached to is displayed because at the point of instantiating the subnet, the VPC already exists, so Terraform knows this. So pretty cool. So take my word for it, and I'll show you in a minute for sure that we do have resources in a cloud environment, AWS namely. And so then to get more details on what has been deployed to AWS or whatever your destination may be based on the providers you're using, you can do a Terraform show. So let me actually, this a little higher up on the screen. So Terraform show, and there we go. We have all sorts of information here about what's been created, account IDs, which I think is not the best to show, so I'm going to skip off of this. So at this point, let's go ahead and go out to AWS and look at the things that we actually have created. So at this point, if you want to look at your resources and search for them by tag, if you go into resource groups and then tag editor, it will take you to this screen. Let me zoom in just a touch. Select a region, US East 1. I would like to see all resources. And then the tag is cost center as such. And then the tag itself is tf-hello world. And so where did those come from? Those came from, let's see here, going back. Within the Terraform configuration, there is a chunk called tags, or an object called tags, and so we specify cost center and then tf-hello world. So that's how this got to be defined. So at this point, within US East 1, we want to see all resource types with the tag key cost center value tf-hello world. Go out and search for the things. And so if you do not specify a name in your Terraform configuration files, your HashiCorp configuration language, it will go ahead and give you some pretty generated looking names. But nonetheless, you do have an EC2 VPC and an EC2 subnet. So let's go ahead and just dive into the VPC, take a look at it, make sure it looks okay. So here, come into the description. So we see that VPC ID. That should be the same that we saw in that subnet earlier. We have our v4 CIDR block of 192.168.225-24, giving us 0 through 255 on that last octet of the IP address range. We did not specify a v6 CIDR range. It creates an ACL by default. Creates a route table. In our later examples, it's more complicated. We'll actually get into defining routes in that route table. And so with that being the case, jumping back into the tag editor, we can go ahead and jump into the subnet itself and just give it a quick sanity check. So with that being the case, we've got the subnet that's associated with the VPC we looked at. We give it 123 addresses, roughly half the space. The beginning part of the CIDR range is reserved for certain things. It's got its own network ACL and route table, likely coming from the VPC's defaults itself. And again, we see our CIDR range here that was defined within the HashiCorp configuration language file that we use to instantiate our Hello World stack. So that's pretty cool. We have made things in Terraform. So we, at this point, let me zoom a little out. Actually, let me just go to presentation mode real quick. So at this point, we have applied the Terraform and entered yes at the prompt. And it goes ahead and shows you what it is creating. And then we also saw Terraform show, which gives you the detailed information about things created based on the Terraform files in the directory that you are in. So we've also taken a look at the resources. We found them via tag. Probably worth noting, I highly recommend tagging your resources when creating them programmatically. Otherwise, you could end up with a bunch of generated names and no real good way to go and find those. That would be terribly unsustainable, in my opinion. So give yourself a way to find your resources. Another way to do that would be to put things in a resource group, having different accounts for different development teams. A few different ways to go about that, but at the most basic level, just tag your things, and you can find them by querying for the tags. So at this point, we're going to kind of close the chapter on Terraform Hello World. The last thing that we need to do is to go ahead and destroy the resources that were created. And so, with that being the case, actually, I won't show my screen over there unless I get out of the presentation. 1 second. So it's as simple as a Terraform destroy. Misspell. Destroy. Thank you. That is my biggest weakness. I would call it the width of my fingers. So here it gives you a little bit of status in terms of what it's doing. It tells you what it's going to do if you don't give it a flag to go ahead and do it. So at this point, it is prompting me to delete the main subnet and then the main VPC. This is in reverse order. That goes back to that dependency graph where the subnet depends on the VPC. Just nuking the VPC first would be a little, I think, forceful. So it's going to do things in reverse order. So with that being the case, given these are very simple resources very quick resources to deploy and destroy, it's going to go ahead and do those, and we get pretty quick feedback that everything's been destroyed. And so with that being the case, given I like to trust but verify, let's go ahead back into the resource or the tag editor, US East 1, cost center TF Hello World, search resources, and they are in fact gone. So at this point, we've walked through kind of creating your own, your kind of Hello World, start from scratch. We're going to provision some resources. And so that's just a quick foray into that. So at this point, what can you do? You can go into the list of Terraform providers. Since this is an AWS meetup, let's do that. And you can go and find various resources for whatever it is that you need to create. And Terraform, the website, will give you the syntax to create that. So now at this point, you are equipped to programmatically from your local command line create AWS resources using Terraform. And so if you wanted to go out and work on your next project, just go to the docs around the AWS provider, and they will give you everything you need to know to get going. And so at this point, for example, to create an Athena database, which needs to be backed by an S3 bucket, you have the ability to go ahead and create the syntax required to create your S3 bucket, as well as the Athena database that will sit on top of it. Athena gives you, in case you're not aware, ability to query S3 buckets. It's pretty awesome. It gets a little expensive, but it's really pretty good. We see a lot of people using it for kind of the interrogation phase of data science, to where dump a bunch of stuff into a bucket and let your data scientists go out and figure out commonalities, if you will, correlations, basically do some exploration and prodding into the data prior to building models, for example. Another thing that you will find on these Terraform provider pages when you get into specific resources, such as AWS Athena databases, is they will give you the complete list of arguments that the resource can accept. Some required, most of them are not. And so with that being the case, kind of taking what we've looked at, marrying that with the very good documentation from Terraform's website, you can basically then go out and start constructing your own infrastructure stacks and just kind of run from there. For the purposes of this talk, I'm going to get into a little bit more complicated stack that I've created that you all should feel free to use if it's useful to you. So getting back into the presentation, I have what is called, and we used this in the CloudFormation meetup last time, so if you're here, this will look slightly familiar. Within my repo shared on the meetup, you can get into my repo. You can clone it. I would recommend cloning it if you want to kind of follow along. There's a repo with 5 files in it with the TF extension. There are more files, of course, but there are 5 Terraform files, 5 applicable files to what we're talking about right now. The first is the vars.tf file, which defines all of the variables provided or used across all of the Terraform resources. Secondly, there's a provider.tf file. This is used to kind of encapsulate the various providers that you use throughout your resources. In the case of multi-region deployments, you can give providers an alias, and then each resource can actually mention which provider it's going to use. So you can get into multi-region deployments that way. So in that case, you would have 2 providers in your provider.tf file, and you can just refer to them via alias. And then in terms of the HashiCorp configuration language files that define the resources within the stack that I'm going to create, and we can take a deeper dive into very shortly, the network.tf file declares network resources such as subnets, VPCs, some of the stuff we've already seen. Additionally, the EC2.tf file instantiates a EC2 instance that is intended to serve up web content, and also the security group that allows traffic on 8080 and 22. So therefore you could SSH into it or serve up web traffic. Pretty straightforward stuff there. And then finally there's an RDS file that defines the database resources.
AWS?
Yeah, come on in. Yeah, grab some pizza if you're hungry.
Can I ask questions while you're...
Oh, absolutely. Yeah, more the merrier.
So TF uses the AWS CLI underneath to talk to AWS.
Correct.
So when you created your AWS credentials, are you using the default named profile, and therefore you didn't have to tell Terraform which credentials profile name that you're using?
Yeah.
Use the default. Okay. So I assume if you have another credentials profile with a different name somewhere in the Terraform command line, you can specify what credentials profile name to use.
Yeah, and so for the live stream, the question is with multiple credential profiles within your AWS credential file, .credential file, how to use most of them or multiple of them, just to kind of synthesize your question. And different providers can specify different credentials or different profiles within that credential file. So you'd probably specify that at the provider level, and then you could refer to the various providers to a provider alias, and that's how you could kind of get around, or you can support that use case, if you will.
One more question.
Sure.
So I use CloudFormation a lot. So I noticed that, so it looks like CloudFormation creates these resources directly through the CLI and does not create a stack.
That's
with
correct.
those resources in it.
Yeah. So I suspect you could probably script that out in Terraform. I haven't done that. There's got to be some really good ways to group that. This is kind of an intro level class. We've got a survey we're going to send out after this where we're going to ask about things you'd like to see in the future. So please fill that out, and we'd love to get into that. I could see a class in the future where we get into more advanced use cases around like grouping resources, creating stacks, integrating with a CI/CD pipeline, really getting into some of the features of Terraform Cloud as well. So, yeah, that may be at a future date. Yeah, please.
Do you know if Terraform can be used to manage infrastructure on different providers simultaneously, where they can communicate with each other? For instance, if something happens to go wrong with the capacity of, say, Azure,
Mm-hmm.
you could increase the load on AWS.
Oh, so the question is, can you do, just to synthesize, conditional provisioning based on multiple resources on different providers?
Yes.
So my answer is I do not know. I frankly don't know. That feels like it's a pretty big lift. You may be able to get into some conditional processing, but I don't know the solution to that problem. So, yeah.
Definitely touch both at the same time.
Yeah.
If you're getting into trying to dynamically manage two ASG type resources, you quickly turn into well, typical ASG problems or any kind of large scale problems. But you can have multiple providers.
Yes.
So like you define the AWS provider with your resource for that, you bring in the GCP provider in the same TF domain, and you could use both of them. You get a little weird because there's no dependency management on those right now. Terraform wouldn't know you need a subnet in GCP and you want to assign an EC2 resource to it, so you'd be manually doing that. But it's doable.
Yeah.
For bigger folks that are running entirely multi-cloud stuff, it's definitely there. You could also end up calling entirely different TF groups with another kind of scaling kind of overlord as well. Quickly end up with very big build.
Something that runs independently.
Yeah.
Yeah, that's a good point. And so just to jump into multiple providers, for example, here where I have a resource, I'm going to go ahead and create a security group. The prefix here is AWS underscore. If you bring in multiple providers, you could have Azure underscore, AWS underscore. It works in VMware, so you could do things on-prem in a vSphere environment. Obviously, vSphere can be in a cloud as well. So you have a lot of different providers, and you can spin up resources in all of those providers, but that kind of dependency and dynamic scaling, I don't have an answer to that. That's pretty interesting. Another thing is probably worth noting is with multiple providers, I think you probably break your dependency graph because technically there isn't a dependency. If you create a VNet in Azure and you have a subnet in AWS, like the subnet in AWS can't be dependent upon the VNet in Azure. And so the resources wouldn't be graphed together from a dependency standpoint. Not that that would be something you actually need. That's basically like standalone resource graphs at that point for each different provider.
Thanks.
Yeah, of course. Yeah, good question. Oh wait, I realized that it didn't show that on the screen. Sorry. I'll get into that provider prefix here in a few minutes. We're about to dive into the files. So a quick overview of what it is that we are going to create at this point. So within AWS, we have a region, and within that region, there's a VPC. So that's the start of what we're instantiating as the VPC. Obviously, we're not creating a region. Within it, there is a public subnet, and it has a security group within it that the EC2 hosting instance lives in. That security group allows communication inwards or ingress communications on 22 and 8080. Secondly, we have a subnet group and a security group that the subnet that is in availability zone A and availability zone B lives within. That security group allows traffic from 3306, MySQL traffic, only from the instance security group. So effectively what we have here is a database that can be communicated with from the public subnet security group, but from the internet you cannot get to the database itself. So at that point we have a public subnet and then 2 private subnets within a subnet group. Additionally, a couple other things just to create to allow traffic to flow. We have a route table association, an internet gateway, and a default route to get traffic back out to the internet. Without the default route, traffic will never be able to egress, so your website would not be able to be served up. The request would get in, but not out. So to kind of quickly run through the individual components, we're going to create a VPC, virtual private cloud, provision logically isolated section of AWS Cloud, give it a CIDR block, etc. It is a software-defined networking component. The public subnet is within the VPC where we're going to put our EC2 instance. Route table to control where traffic is directed to. The internet gateway, which allows traffic in and out of the VPC. The route table association, which attaches the route table basically to the VPC. A default route that allows traffic back out of the VPC. From an EC2 standpoint, we're going to create an instance, which is just a virtual machine. We're going to use one of Amazon's Linux images for that. We are going to also create the EC2 Instance Security Group, which defines what traffic can flow to and from and on what ports that can occur. And then finally, the RDS components, the Relational Database Service, that is going to be a Platform as a Service database instance. Since this is set up to be able to support multi-zone failover capabilities, we'll have a primary subnet and a failover subnet. These both live within a subnet group, which RDS is attached to. And then finally, the RDS group in which the traffic source destination ports are defined in terms of allowing traffic to and from the RDS instance. And so to dive a little bit further into the HashiCorp configuration language file blocks, we've taken a look at a provider, I believe, at this point. But let's go ahead and just dive into the various aspects of the solution. And so firstly, let's get into the provider. Since we are only doing things in AWS, I simply have the AWS provider. Here you could create a second provider in a second region. It would have to be of AWS, but you could give it an alias, and then later on you could refer to that provider alias if you want to instantiate things in multiple regions. And then at this point we also have a resource block within a Terraform HCL file, and that is, let's take a quick look at that. Getting into just the networking components. And the first resource block is the VPC itself. And so the resources very intuitively are the individual things, if you will, that are going to be stood up within AWS. And so jumping into kind of the anatomy of the Terraform file further, the third type of block that we use within the repository is a data block. And so this is a block that is used to go and get information. And so I use it to get the ID of the latest Amazon machine image. Let's see here. So this section here, the AWS AMI. And so here we're going to go get the most recent AMI, where it is of the Amazon AMI. So these are the Amazon Linux images that can be virtualized via the HVM engine. And so this allows you a mechanism to go and look up data. If a new machine image is released, you don't want to have to go and actually change your file and commit it to source code and redeploy it. You really want that to just be something that can be looked up dynamically at runtime. And so the data block gives you that, that capability. Okay, and so at this point, if you all have the repo cloned, we can go ahead and take a look at, actually let's go ahead and dive into the individual files and cover those a little bit more, sorry. So in the vars tf file, we have all of the variables used across the resources that are created. And so the base of the CIDR range, there's probably a smoother way to do this. So we're going to start at 192.168.200. We have a cost center that we're going to apply in tagging to every resource we create. We'll use this to look up resources within the tag editor, as we've already done. The region that we want to instantiate our resources in, the username for the database that we're going to create, the password for the database that we're going to create, the location in which we're going to allow SSH traffic into the EC2 instance. At this point, we're just going to allow it from anywhere, unless you all specify otherwise in your parameters. The instance type, going to default to a T2 small. And then also the EC2 key name for the EC2 instance. If you all, we created this earlier, in order to SSH into the EC2 instance, this will be the name of the key that has to be used. So, with that being the case, actually, did we get into creating the key? Okay, so let's just go ahead and do a quick run through in the console in terms of creating the EC2 key. And so, within the EC2 service, click and wait. Down in the bottom left, there is a key pairs link. And so at this point, if you need to create an EC2 key pair, and it looks like I delete, no, I've got the AWS Meetup Group key. And so to create a key pair, you simply name it. I'll go ahead and give it a -2 and create it so we can walk through this. And it's going to automatically download your PIM file. And so if you're familiar with SSH, go ahead and throw this PIM file into your .ssh directory and then give it read access or 400 access. So at this point, that would look something like what is the name of this? Yeah, so that's downloads -2. Okay, so I think at this point I'm in the wrong directory. So at this point it's simply copy from downloads here into your SSH folder locally. As a Mac user, that's just the .ssh folder at your user's root, and you'll want to do a chmod 400 to the key. So at this point, you can use it to SSH into things. I don't know if we're going to really get into tunneling into the box today, but this is important in case when you want to use the instance, you'll need this key. And also, if the key is not created, the actual Terraform script should probably fail because you're referencing a key that doesn't exist. So it's not a real thing for me. Cool. So at this point, this is where I have cloned the repo into. And so at this point, we can see that I've got the TF files here. And let's see. Oh yeah, vars down here. That's what I was looking for. So at this point, we've gone through the basic commands of Terraform. So let's go ahead and take a look at, this has already been initialized, I'm pretty sure, since I was doing this earlier. But at this point, we can see, given this more complex stack, what it is that it's going to deploy. So I'm going to go ahead and start I'm going to plan real quick and apply, and then I'll jump into the actual files themselves, and we can take a look at all of the resources that are to be created. So on the planning stage, we see that we're going to add 13 resources, nothing to change or destroy. So let's go ahead and do that. So it'll go through the process of refreshing state, figuring out what it needs to do, prompts you to figure out if you would like to go ahead and deploy those things. I'm going to say yes, and this is going to take a little bit of time. So let's go ahead and jump into the actual resources that are to be deployed. So let's start with network. We are going to create a VPC using that VPC base -0, so 192.168.200-0 with a /24 subnet mask. So this will give us 255 addresses. We are going to enable DNS and host names within it and tag it with our cost center. Then we'll create the public subnet, give it roughly half of the addresses available within the CIDR block of the VPC. Create a main DB subnet, give it roughly a quarter of the addresses. Let's see, from the halfway point to the 3/4 point, if you will. Hopefully that makes sense. And then we'll create the failover subnet and give it the last quarter of the CIDR address range available to the VPC. At this point, we will also create the internet gateway. This allows communication in and out of the subnet. We'll create a route table that we're going to go ahead and create some rules for. We will associate the route table with the subnet. So we're going to associate this to the public subnet. And we're also going to make this, we're going to go ahead and define a default route for the VPC itself. And so we are going to direct all traffic that's not within the VPC out to the internet gateway. So that allows us to get traffic out of our VPC. So with that being the case, let's jump into the EC2 resources and just take a quick look at the architecture diagram again as a refresher. Not sure where that arrow came from. So at this point, we've defined the VPC, the subnets, and we've also defined the route table, associated it, defined a default route, and the internet gateway. And so it's the kind of the core of the networking components here. Within the EC2.tf file, we're going to look up the most recent Amazon machine image for Amazon's Linux distribution. We will, well, not Amazon's Linux distribution, what they package up for a Linux distribution. We will create a security group that the EC2 instance is attached to. And this is going to allow inbound traffic on port 22 from the SSH location we saw earlier in the vars file. It's also going to allow inbound traffic on 8080 from anywhere. So this allows inbound traffic on 8080 from the internet, essentially. And then we're going to create, this egress rule is created by default when you do things through the portal, or the console, if you will. You have to create this manually in both Terraform and Pulumi. And so we're basically going to say from port to port 0, which is all ports, all well-known ports, which is like 2 to the 16th, which is like up to 65,000 in some. So 0 through 65,000 in some. -1 is any protocol, and we are going to allow, we're going to send that back out to the internet. 0s-0 is a kind of the CIDR block that represents the wider internet, if you will. And then finally, we're going to create an AWS instance. I'm calling it web, whereas port 8080 is intended for web traffic in my mind, so I'm just calling it web. So we're going to go ahead and get that instance type that came from the vars file. It wants the Amazon machine image. Sometimes this is called an AMI, the ID of that. And so it's going to go ahead and look that up from that data block up here. And so here you can say data, AWS AMI, Amazon ID. So this is actually referencing another resource within the same file, in this particular case a data block. It takes that key name that we talked about earlier. It's going to go ahead and give the EC2 instance a public IP address. It's going to place it within that public subnet, and the security group that we are going to assign it to is that EC2 security group. So I know this is a lot, but I just want to walk through all the things that we are creating. And so the final bit of this is the RDS resources. And so firstly, we're going to create a subnet group, which is required when doing high availability with your RDS database. And so within that group, we're going to have the main subnet as well as the failover subnet. We're also going to create a database security group. And so this is going to live within our main VPC. You associate security groups with a VPC. And so at this point, it's going to allow ingress or inbound traffic on 3306 and TCP protocol. And the source of this, we don't have a CIDR block here for the source of this. We're only going to allow that from that EC2 security group. So this is kind of cool. At this point, the security group is in another file. Allows you to organize things in a kind of sane manner, if you will, but you can most certainly reference resources across files within your Terraform project. And so with that being the case, we are going to allow ingress traffic on 3306 from the EC2 security group. So that keeps it locked down, and so at this point we have the public subnet accepting 80, 80, and 22 from the wider internet, and we have the RDS security group only accepting 3306 from the EC2 security group. So that's how we establish that public subnet, or private subnets paradigm, because you don't want your database open to the wider internet. If you're subject to any kind of compliance frameworks, they will get very mad at you for that. And so finally, we're going to stand up a AWS database instance. This is the RDS instance. It's got allocated storage, that's gigabytes. I won't run through all of these. Worth noting that we have the user and password coming in from the variables file. We're just going to go ahead and take the defaults if that's not specified in the command line or whatever CI/CD pipeline you're using to go ahead and plan and apply your Terraform. We specify a subnet group name. So that we can get that failover. If you have a subnet group with only one subnet or two subnets in the same availability zone, this will explode and tell you that for multi-AZ, you need multiple subnets. Couple pretty important notes here. I do not have multi-AZ turned on at this point. I've got it commented out. Comments in Terraform are just the pound sign or the hashtag sign, if you will. If we turn on multi-AZ, the deployment time goes from 5 minutes to 15 minutes. So if you all want to use this and deploy multi-AZ RDS databases, feel free. Just note that you need to uncomment that. And then finally, the skip final snapshot. When you go to delete an RDS instance, it wants you to create a final snapshot of the database, which is effectively a backup. If you go ahead and set this to true, you can destroy the RDS instance without doing that final snapshot. That's something that you have to basically force Amazon into allowing you to do. And so with that being the case, I've included skip final snapshot just so I can do a Terraform destroy without having to go and manually set the snapshot name through the portal. There's also an argument to set what the snapshot name would be if you want to enforce the creation of basically a backup of your data in your database upon destroying it. Given this is just a demo, I just wanted it to let me destroy the resources without complaining. So that's that skip final snapshot equals true parameter there. So I know I've talked a lot, so let's go see how things are doing. Okay, so at this point, creation complete after 4 minutes and 12 seconds. Just kind of tailing back through the logs. We'll probably have to go quite a while. It'll give you kind of the running ledger of things being created. And the RDS instance is by far the most timely resource to create. So when it comes down to the end of it, you end up seeing this still creating. So after 40 seconds, everything was created except for the RDS instance. And it took another 4 minutes and 30 seconds to create that instance. So it'll kind of give you a running tally of what it's doing if you follow the command line. So with all that being said, let's go ahead and take a look at the resources within AWS. So back into the tag editor, we'll say we want all resource types. At this point, if you recall, the tag that we put on the IaaS hosting stack, all of the things that were created, involves a cost center tag with a value that is set to AWS Meetup Group, separated by hyphens, of course. So at this point, we can go ahead and put that criteria in here. And I'm going to zoom out just a touch. Hopefully you all can see that. We've got an instance, the internet gateway, the route table. We've got a security group. Back to the point I was making earlier, I haven't put any names on these, so it's hard to really tell what these belong to. So I would highly recommend in a production scenario giving some sort of meaningful name to your resources. 3 subnets, the public and the 2 privates, the VPC itself, the database instance, as well as the DB subnet group. And so just a kind of quick stroll around the resources. Let's click into the RDS instance and take a look at it. So zoom in just a touch. So we have, if you were to go into, let's go ahead and capture this name. I think it'll be obvious later, but if you were to just go into the portal, go into the RDS service, it'll show you all of the RDS databases you have. This is kind of a sandbox, so it's pretty trivial to find our things. In a larger production environment, that may not be the case. So again, tagging good names, please do that. So at this point, some takeaways are you can get the endpoint name. And so if you were to like write code and deploy it to the EC2 instance, this would be the endpoint or host name that you need to direct your database traffic to. Its availability zone is US East 1B. So it's available if we had the HA, we might see 1A, for example, there. This thing is associated with 2 different subnets, the main and the failover. And so we're starting to see some of those things that we defined in Terraform showing up as subnets in this particular case. So kind of going back over here, so we see our 2 subnets. We see our security group. This is very important. Without proper security group setup, inbound traffic does not work. And so in here, we should see 3306. And so here we can see 3306 is allowed from the security group name SG0B ... So this is what's going to allow your inbound traffic. Outbound, we don't have that defined. Going back over into the resources. I won't go into every single resource, but I think the most noteworthy are the DB instance, because you're going to need to go and find that endpoint address. If you did a Terraform show, it would also show you that metadata as well. And then also the EC2 instance has some pretty good information in it that you're going to need. So at this point, you've got the public DNS name, the public IP. It's got private DNS, private IP. That private IP falls within that CIDR range that we defined for the public subnet. Availability zones, security groups. So let's take a quick look at the security group. Inbound, 808022. Is this what we wanted? Cool. So I think at this point, just a quick sanity check. I'm going to take this. So at this point, if you wanted to get into here and SSH into it, we'll take that public DNS hostname. And so it'll be SSH-I, give it the location of your PIM file, which we downloaded earlier. For this particular machine image, you will need the username EC2-user. For other machine images, it could be Ubuntu, and then the public DNS name. So just as a quick sanity check, we have SSH into the box. If we wanted to install npm and spin up a website, that would most certainly work. We can do that pretty quickly. So within the CloudFormation meetup, I've got some commands to just very quickly install a pretty lightweight server. I think that's okay. Looks like the npm install did not work. I'm not sure why that happened, but we're fixing it now. Coolio. At this point, we should be able to serve up, install and serve up our website. So just another quick sanity check that we've got 8080 open, and we'll move on from this after I show you all the little template website that I've got stood up. So we'll give that a second to get going. Go ahead and get this public DNS name again. So give me a second here. So we're going to go ahead and build the Vue.js starter site. Eventually. Cool. And then finally, we're going to serve this bad boy up. So we are now listening on port 8080, which is conveniently the same port that we configured our security group to allow traffic inbound from. So here we go. So now on our EC2 instance, we have a website running. So that was, like I said, just a quick sanity check and also kind of proof that what I'm showing you all how to build does actually work the way that it does. If you go back into the CloudFormation meetup, there's some instructions as to how to install MySQL on the EC2 instance and connect the MySQL client, create tables, stuff of that nature, etc. So,
and you can do all that using the console, right? Using the AWS console.
oh, the creation of like the EC2 instance and the VPCs and all that stuff, yeah, for sure. So this is just automating the creation of resources so you get like a predictable environment, a repeatable, environment, stuff of that nature. Yeah, absolutely. So pretty much all of this stuff can be done through the console. Stuff I just did, installing and serving up a Vue.js starter site. You probably have to use something like AWS config to do that, or create your own Amazon machine image if you wanted to do that. But the instantiation of all those resources most certainly can be done from the command line. Or from the console. I'm sorry. Yep. All right. Cool.
Quick question.
Sure.
So Terraform is mainly infrastructure. You're not going to deploy, like you do SSH, then you deploy your web stack.
That's correct.
So for application stacks, you're still going to use like an Ansible or some other configuration.
That would be the recommendation, yes. AWS configuration works as well.
Okay.
Or creating, if you wanted to do it all in Terraform, you could create your own machine image. I personally think that's a pain in the butt and wouldn't recommend it, but if you want to get real crazy and do that, it's a possibility. Did you have a question?
I just said it was the way to go. I was being.
Oh, okay. I thought you said you had a question a couple minutes ago.
I was giving good advice.
Oh, yeah, solid. As organizer, you have to give people advice. Cool. So with all that being said, I'm going to go ahead and get out of the EC2 instance, maybe stop yelling at it first. And so we've closed our connection. So at this point, pretty simple. We can just go with the Terraform destroy, and this is going to go ahead and nuke everything. So definitely worth noting, do destroy the resources you create, otherwise you're going to get a bill for them. If you were to follow along, you'd probably get a very tiny bill for this, since you do have compute cycles that you are accountable for. So, anywho, so with all that being said, that is the Terraform portion of tonight's meetup. Let's go ahead and jump into another technology that I find to be pretty darn interesting. So, there's a company called Pulumi, based out of the Seattle area, if I'm not mistaken, venture capital funded, only really come onto the scene within the last couple of years. And so I included their marketing fluff, but it's pretty close to true, so that's why I included it. It allows you to use the language, your favorite languages, to deploy to any cloud. That's almost true. They do not have an Alibaba cloud provider, so I caught them on that. But it does allow you to use languages that you are using for your application development to actually code your infrastructure. So this looks like JavaScript, TypeScript, anything that can be used in a Node.js runtime. Python, .NET Core, and Go are in preview. And so those are coming along nicely. That's actually, I've been kind of following the progress there, and they are actively contributing to the repo. So in order to get started with Pulumi, to do anything from the command line, you will need an access token. So I'm going to jump out of the slideshow real quick. Please bear with me. So if you go out to, let's just do hello, incognito window, don't have any credentials in here. It's going to make you sign up. So I signed up with my GitHub account. You can link into your GitHub account. You can also do some basic auth with an email address. I'm sure they're going to make you verify your email, kind of standard stuff. So with that being the case, once you create a Pulumi account, let's just go ahead, create that account, then go back to tokens. Once you go into your profile, you have access tokens. So if you were to go to the root of the site, it'd be like, hello, into your account. Within this, you will need to create an access token. So this is as simple as, call this meetup day, the token. And so that will give you this access token. You'll want to copy that and keep it somewhere. You will only see this one time. So upon creating your Pulumi access token, do store it somewhere. Since I've shown this on YouTube, I'm going to delete that. Cool. So at this point, get into Pulumi. Cool. So we'll go back to the directory we were working in. And so within the repo, there is a directory called Pulumi IS Hosting Stack. So if we get into there, I've converted the Pulumi or the Terraform HashiCorp configuration language files, and that goes into an index.ts. You can do this in Python, various languages. I did it in TypeScript. It seems to me that Pulumi seems to be pretty mature around Python and TypeScript, so that'd be my recommendation in terms of languages. But you've got those 5 choices that I showed you, so do feel free to use whatever you're most comfortable with. And so this is what the Pulumi file looks like. Looks a lot like JavaScript. So at this point, we've got some variables at the top. We've got some providers, and then each of the resources is instantiated as a constant variable. So here we've got the main VPC. This should look very similar. Instead of, for example, on the VPC where you've got the underscore separating your property names, this is going to just use a camel case naming convention. So there's small differences, but I think it's all fairly intuitive. So kind of going back through the resources as we saw in Terraform, this should all look very, very familiar. I used an automated converter to create this from Terraform, and I'll show that to you before the end of tonight's class. And so it just threw everything in an index.ts file. There's no reason you couldn't break this up and just import star from whatever your file names are. So you could create a network.ts, a network, or a EC2.ts, and a RDS.ts. And you can just import those, very similar to how you think about importing resources in, like, for example, a Vue.js site or any other JavaScript framework. And so with that being the case, in order to do things with Pulumi, the first thing that you will want to do is install Pulumi. So brew install Pulumi. If you're on Windows, you can use the chocolatey package manager. If you want to get real crazy and do things by hand, I've got this command. Feel free to use it if that's what you're into. And so brew install Pulumi. And once you install Pulumi, you're going to want to install the AWS resource, or the AWS plugin. And so the current version is 1.18.0. So Pulumi plugin install resource AWS 1.18.0. So at that point, get into the directory in question. And so I am already there, the Pulumi IaaS hosting stack. Let me get this closer to the top of the screen, maybe make it larger. And so at this point, you will want to initialize your stack. And so if you have not logged in before, it will prompt you for your token that we just went through creating within your profile. So once you give it a token, it knows what organization or account that you are operating within. If you do a Pulumi stack init within a directory, it's going to assume the directory name is your stack name, or your product name, and then you give it a stack name. The default here is dev, and so it's going to go ahead and create that. So what we've got here out in Pulumi is now, and within my organization, I have the IaaS hosting stack and the dev instance of it. So you can create a dev, prod, so on and so forth. Just for the purposes of this meetup, I'm going to stick with dev. So let's click into this. Nothing's happened. Yeah, that makes sense. We just instantiated it. Let's go back and do the things. So, excuse my hopping around the windows. One thing that is worth noting is the AWS module to deploy to needs to be installed locally. So an npm install at Pulumi/AWS will do that. I believe I've already got that installed, but let's go ahead and do that. Cool. So at this point, it's time to deploy the things. So Pulumi simply uses Pulumi up to instantiate a stack. It'll go through a preview process similar to the plan process that Terraform uses. Oh goodness. So another thing with Pulumi is you will need to set the region. And so I have not messed around with multi-region deployments in Pulumi. So that's a thing that's probably worth looking into. I'm sure there's a way to do it. I just currently do not know that way. So at this point, now that it knows which region that it's supposed to be operating within, it will go ahead and take a look at the preview for resources to create. It will prompt you, and again, you can give it command line arguments to not make it so needy. Go ahead and say, yes, I would like to do this. And it's going to go through and create the same resources. So this takes about 4 minutes and 20 seconds, as we saw in Terraform. So let's go ahead and jump into the process of converting from Terraform to Pulumi. Let me find a decent size here. Actually, let me just go ahead and get into presentation mode. So there is a utility that's actually made by Pulumi. It's within Pulumi's GitHub organization called TF2Pulumi or Terraform to Pulumi. It requires some dependencies, so you'll need to install Go and dep if you want to install the dev version of it. Or you can get the binary, which is the easiest way to get going. For Mac, just get the Darwin version of it. And so what I did was I downloaded the TF2Pulumi binary and put it in my root. And so at that point, if you want to execute things, you have to go ahead and give yourself permission to execute them. Safety feature of the operating system. So chmod +x root / TF2Pulumi. And so at that point, you have downloaded the binary and went ahead and gave yourself permissions to execute it. So with that being the case, let's see here. I'm going to go ahead and, since we are actively deploying something, I'm going to, actually, sorry, I'm on the struggle bus here. Let's get ourselves another tab, make it larger. Into, actually, good. So I think, actually, let's go ahead and just, sorry, bear with me. I'm being a little silly. So back into the Terraform. So what's going on here is we already have this Pulumi IS hosting stack, which we did a knit on, which created a space out in the Pulumi Cloud. So at this point, we need to create another stack if we want to do this conversion. So with all that being said, I'm going to call it stack 2. So it'll take a few arguments here. Go ahead and grab some dependencies. Cool, and we're good. So at this point, we have created the stack from the command line. So if we were to take a look at that, it goes ahead and creates these pretty basic things. So if we want to take a look at the index.ts file, it's just a it's basically an empty file with that import of Pulumi alone. So that's cool. We're on the path, but we're not quite there yet. With all that being said, we went ahead and took all the defaults there. Feel like, so what we're doing here is within this directory that has, I'm going to copy this guy. So we're in the directory that has, oh man, what's going on here? Having a hard time. So we have a bunch of, oh, TF, cool. Awesome. So we have all of our Terraform files in here, the EC2, the network, the provider, the RDS, and the vars. So it'll go out and find all of these TF files and go ahead and convert them into a Pulumi TypeScript file. And so what we'll want to do is, let's see. We've got this TF2Pulumi utility, and we're going to tell it where to send things to. So we're going to go ahead and send it out to the Pulumi IS hosting stack 2. Then want to overwrite the original one since we're deploying resources from it. We'll go back to that in a second. And very quickly, it's gone ahead and converted all of your Terraform into a single TypeScript file. And so that's really cool. It can also convert from CloudFormation as well. So I think it's a pretty powerful utility. It's worth noting it does a pretty good job, but you'll still have to get in and install the Pulumi AWS provider within that directory. So have to do that again. And honestly, if you source control this, you'd probably put this Pulumi AWS package in your package.json and just do an npm install and be good to go.
Is that a common practice to move it from Terraform to Pulumi? Is that common?
I think people will, I don't think it's uncommon. I think most organizations will pick one and go with it. But if you find that you have a development team that wants to do stuff in TypeScript, then you may want to convert it. So it is kind of an edge use case, but it's something that people do. I think you'd probably start with the technology that you like best now that you're armed with all of this knowledge, and just make a pick based on what you know and what your dev team knows. So it's also worth noting that if we did this to JavaScript, this wouldn't be as big of an issue. But if we get into stack 2 and look at the index if you tried to run this straight away, the issue you'd have is instance type is not of type string, and these parameters are returning just string values. So given TypeScript is a strongly typed language, we need to go ahead and coerce into the type that instance type is expected to be, if that makes sense. So we'll take whatever you give us from the command line or the default and go ahead and convert that to an AWS EC2 instance type. So that is definitely a gotcha. So wanted to call that out explicitly. So these instructions are kind of starting from scratch, not assuming the stuff that we did earlier. So again, set your region, do a Pulumi up, and it will go ahead and instantiate your resources. If you want to make some changes to your Pulumi resource definition and then update it, it's just Pulumi update. Pretty intuitive stuff. And so going back over to the command line, Pulumi has finished instantiating the resources that we defined. And so let's go back out to the tag viewer, or tag editor, and just go ahead and give it a quick trust but verify. Let's see here. Security things, timed out, cool. Bear with me. Resource groups, tag editor, and this should look very familiar. If you recall, we went ahead and destroyed our Terraform resources, so this is all coming from that recent Pulumi deployment that we have done. Maybe? Maybe not. Oh yes, all resources. EC2 Instance, AWS Meetup Group. Interesting. What is going on? So I am having some sort of demo bug. All resource types, list one.
What's the issue with it?
I am not seeing my resources. So that's pretty interesting. I'm not sure why those aren't showing up. Let's take a look in Pulumi and figure that out. So
This would be like how you would debug it in like a development environment.
yeah, like I expected to find it via the tags, and for whatever reason I did not. Within Pulumi, it's got all of the resources that were created as a part of your stack. So at this point, if we wanted to take a look at the EC2 instance, we can go out, or the RDS instance, we can go out and find that. Let's see.
Ryan said he didn't see the Pulumi at
Let's see. No, it was the last command I ran.
Does the Pulumi website show that they're all tagged?
Let's see. It may actually be created. I think it. Yeah, it looks like it is done. We got 14 created, 4.5 minutes. So. We've got ARNs and everything. Some of these will have links out to the portal itself. So let's go take a look at the tags. Oh, okay. I'm a fool. I put a different value in that file. My bad. My bad. My bad.
You name the tag something else? Or?
Yeah, I gave it my last name. So that actually explains everything. It did exactly what I told it to. Oh, yeah. So I was looking at the generated file, and I messed around last night and gave it a different cost center tag just so I can go and kind of separate it from the Terraform things as I was proving to myself that this was working. So there is an explanation to this. So going back into tag editor, resource types, cost center 10, search the resources, and we have all sorts of things that have been tagged. So we are in a similar scenario as earlier with Terraform, where we have the instance, the RDS database, VPCs, subnets, etc. So this is an alternative to Terraform that we're pretty excited about, given it uses programming languages and not JSON or the HashiCorp configuration language. So I wanted to show an alternative to that. We have about 10 minutes left, so I'm going to go ahead and destroy the resources. And so that's as simple as Pulumi destroy.
I have a question.
Yeah, sure.
So whenever you like have that issue in your debugging, what's like going through your head to like figure out what's wrong with that, as far as like debugging the Pulumi? Because I've never used Pulumi.
Yeah, so I went into the Pulumi. I went into the stack in Pulumi. It showed me the resources, so it also gave me a link to click into the EC2 instance. And so upon clicking into the EC2 instance, I found that the tag was that new value that I had like set manually last night during my debugging, but forgot to unset. So should have reset hard on that repo. So yeah, the portal's certainly helpful. That brings up a good point. You know, if you're using something like Terraform with local state, debugging is going to be a little bit more tricky. I think there's probably some tricks of the trade to go and look through Terraform state and see what it's deployed. I'm honestly not an expert in that area. So really you have to go and look at the state of the deployed resources and go track them down, find a Amazon resource name, something, and go kind of interrogate the resources that were created and figure out what went sideways on you. In this case, manually change parameter default value.
Okay. So why would you use like Pulumi versus Terraform, or like why would you pick one or the other?
I think it's a matter of what the dev team's probably more comfortable with, right? So does your dev team want to use the same like languages that they use for their products? Are things being deployed by an operations team that's already familiar with the HashiCorp configuration language? You know, in the latter, you'd probably go to Terraform because that's what your operation folks are good at and want to support. And the former, you've got a full stack dev team that's kind of taking care of the DevOps, you know, portion of their project, so they're probably more comfortable with TypeScript than HCL. You can stand up.
Gaps in one or the other, like if I like the particular things in AWS and particular resources, as far as like your experience with it, do they both like support pretty much everything in AWS, or is there some gaps in it?
I can't say that they both support the identical amount of resources within AWS. I think it's really close. So there may be gaps.
Does it use the AWS Terraform provider?
It might.
I think it actually uses the underlying.
Oh, does it use the
Yeah.
underlying provider?
Yeah.
Okay, so it would support all the same resources. Yeah, so at that point you have an issue in the providers that are available from Pulumi. I think there's like 10 to 20 of them, and the providers available from Terraform are closer to like 200. So you have like 10 times more providers with Terraform, so you have a little bit more, I think, leeway there. to create different things.
So I did not attend the part one. Was there any other tool introduced in the part one of these?
Oh, no. Oh, part one. So this is the second meetup in a two-part series. In part one, which is a different day, we talked about cloud formation. But today we've talked about Terraform and Pulumi exclusively.
Okay.
Yeah.
So like, I know with Terraform, you can kind of like set up your infrastructure to where you could have like a main file and have like other files, so you have like your infrastructure kind of like broken out. Can you do that same thing, like make it like more modularized with Pulumi as well?
Yeah, and so it kind of follows the constructs of the language. So with my example, you could put your variables in a vars.ts file and import that. So that would be the first step there. Secondly, we broke up networking, EC2, and RDS into different files. You could take the networking components here defined within these variables and put those into a separate file, for example, network.ts, and then just import those. So it's going to be very similar to what you do with JavaScript for to break up a project to make it maintainable. So at that point, you could create a file here. Let's get back over here and take the network things. So you can break it up in the same way that you would break up a JavaScript project. So I'm not sure why this is so mad, but yeah. So I think this is it as. So yeah, you can import things the same way you would do any old JavaScript or TypeScript file. So you just import them. So yeah, you can certainly break that up. Good question, because this would quickly become unsustainable. Yeah, it's like you see those giant CloudFormation or ARM templates, and you're like, man, who could maintain this? You got to break it up. You got to be able to nest structure, etc. So I would imagine as you get into a large infrastructure stack, you end up with directories, etc. So you could have like a network directory, and within it you could have security groups and subnets and VPCs, and so you'd keep breaking it out to make it sustainable as the project grew larger and larger. All right. Are there any questions from the live stream? Okay.
Any other questions?
All right. Well, thank you all for coming out. Hopefully this was helpful. I'll put some business cards out. Wait, hold on. Shameless plug. WWT is hiring across cloud architecture and engineering, software development, QA, UX, pretty much anything within the industry. We are currently looking for people. So reach out to me, Kevin-10 on LinkedIn. Like I said, I'll leave some business cards out, and thanks for your time. I know it's very easy to go to the brewery or home after work, so thanks for taking time to come out and hang out with us, and it's been fun. Hopefully it was a good use of your all's time.
Yeah, and the